Alright, so now we're back to uh, the alumni giving example, and we're at number 4. It says, now create dummy variables to represent the regions of the U.S. and use them in a regression model. What value does including the region of the country add to your analysis? And then number 5, what conclusions and recommendations can you derive from all of this stuff? Right. Alright, so if we go back to here, we came up with, so far, the best thing was to use the graduation rate and the student-faculty ratio as the two independent variables, giving us an adjusted R-squared of 0.686. Graduation rate is a positive coefficient. Student-faculty ratio is negative. Remember why that's okay. And so now what we want to do is we want to look at the region, which is in column C on this worksheet, Alumni 2. This is the one I rearranged, putting graduation rate and student-faculty ratio next to each other so we could run the regression. So we have the South, Midwest, West, and Northeast as the different regions. Right. So when we create dummy variables, what we're doing is it's a indicator variable is another name for it. It's a 1 or a 0. So if we have a variable called Northeast, then the row that contains a college, university, that is in the region of the Northeast, it would contain the number 1 in it. If it was not in the Northeast, like California Institute of Technology here, row 5, then that variable would have a 0 in it, indicating that it's not in the Northeast. So in order to use these categorical dummy variables for a categorical column, like column C, like region, we need the number of categories minus 1 dummy variables. So in this case, we happen to have 4 regions: the Northeast, the South, the Midwest, and the West. So we need 3 dummy variables. The one that we leave out is our base region. We can somewhat arbitrarily choose whichever base region we want. In my case, I'm going to choose West, simply because it's out west and we're in the Northeast. So I'm going to choose 3 different indicator variables, dummy variables: Northeast, South, and Midwest. And then when all 3 of those variables have zeros in them, it must be the other region, which is West. It's our base region. It's important to remember which region we're going to use as our base, because all of the coefficients that come out of the multiple regression are in relation to that base region. So the first thing I'm going to do is copy Alumni 2, and I'm going to put it here. And now it's Alumni 3. I did that because I need to create some more variables, and they need to be contiguous. So I need 3 variables, so I'm going to insert, do that 3 times. This is going to be Northeast. Next is going to be South. And the final dummy variable is going to be Midwest. And so what I want to do is create a multiple regression that uses graduation rate, student-faculty ratio, Northeast, South, Midwest, to try to help us understand what the alumni giving rate looks like. So how do I get these dummy variables? Well, if I go over here, the first university is Boston College. It's in the Northeast, so this would be a 1. So I go through and manually code those, or I'm going to do an if statement. If C2 equals Northeast, return a 1, otherwise return a 0. In this case, it returns a 1 because it's in the Northeast. I do the same thing for the South. If it equals South, I return a 1, otherwise a 0. And of course, because it's already in the Northeast, we know that South must be a 0. Midwest, same thing. If C2 equals Midwest, return a 1, otherwise 0. And so in this case it'd be a 1, 0, 0, indicating that Boston College is in the Northeast. Now I ought to be able to autofill that down. Northeast, Northeast. Let's look at this fifth row, which we said was in the West. There's a 0 in the Northeast, a 0 in the South, 0 in the Midwest. What does that mean? It means that this particular university is not in the Northeast, it's not in the South, it's not in the Midwest. Therefore, it must be in our base, which is West. Here's a Northeast, here's a Midwest one. Okay, let's check the South one, which is right below it, number 8. Looks good, right? So it looks like it's doing what I want to do. So now I ought to be able to go up to Data, Data Analysis, and run the regression. The Y range is the thing I'm trying to predict, which is the alumni giving rate. So now I'm in K1 through K49. My X range is my graduation rate and those 3 dummy variables. So F1 through J49. I have labels. I'm going to put it in a new worksheet ply, and I'm going to click OK. And let's make this bigger. So we see that the adjusted R squared did go up a bit. So it was 68.6%. Now we're at 69.4% for adjusted R squared. Overall, the model is statistically significant. And now we can look at each individual independent variable. Graduation rate has a small p-value. It is statistically significant. Student-faculty ratio is still statistically significant. Northeast, 0.06, so it's not statistically significant at the 5%, but it is at the 10%. South is not significant, even at the 20%, and Midwest is not significant at the any interesting percentage or alpha level. So, what does that mean? Well, the adjusted R squared did go up, not by very much, right? Less than 1%. So it probably may not be worth it to use this new model to help me predict. What can we discern from adding the regions? So notice that the coefficients on all of these 3 dummy variables are positive. This means that the alumni giving rate is bigger than our base region, which is in the West. So Northeast, it appears that schools that have alumni from the Northeastern schools, not Northeastern the university, but universities in the Northeast region, have a stronger or higher alumni giving rate than the West by about 6 percentage points, and from the West, the South has about 4 percentage points higher than the West, and the Midwest about 2% higher than the West. So while that's interesting, none of those are really statistically significant, so I may not want to actually use this model. I might instead want to go back and go look just at graduation rate and student-faculty ratio instead of adding these regions. Although it is somewhat interesting that I found this out, right? I could do this though without a regression. I could group them in a pivot table and figure that out as well, probably. So in this case, adding the region doesn't do a whole lot for me. So I'm still liking this number 3 subset, which is graduation rate and student-faculty ratio. The last question on here was, what conclusions or recommendations can you derive from your analysis? So it appears that the best thing to do using the data that we have is to look at student-faculty ratio and the graduation rate to help me understand what the percentage of alumni giving is going to be. Now, other things that would be interesting is what's the cutoff for determining an alumni giving rate? Is it $5? Is it $25? Is it $1,000? How much? What are we actually tracking here for a giving rate? And then we could think of probably some other interesting variables that we'd like to collect and use in our analysis that were not given to us in the data set. So you might want to think about that as well.